Hey guys, today we are looking at graphing some rational functions. So, first off, a rational function looks like this. P of x divided by Q of x. Where P of x and Q of x are polynomials and Q of x can't equal 0 because we can't divide by 0. Today, P and x and Q of x are going to be linear. In the next lesson, they won't necessarily be linear. So, our parent function, the graph is called a hyperbola, and it's y equals 1 divided by x. That's just the parent function that we'll use. So, it says graph on your graphing calculator. If you don't have your graphing calculator, throw that into Desmos real quick so you can take a look at it, so you know what a hyperbola looks like. I'm going to sketch one up here for you. Here's my x and y axis. And this parent function, the hyperbola, takes up the first quadrant and the third quadrant. And you should see that it has vertical and horizontal asymptotes. It shows you that in the properties. So horizontal asymptote on the x-axis and a vertical asymptote on the y-axis. So our domain and range then is all real numbers except x can't equal 0 and y can't equal 0 on our range. There are two branches. They're symmetric. So you can see that xy corresponds to negative x, negative y on the other branch. So if you look and you have a point 1, 2, you're also going to have a point negative 1, negative 2. That's how that symmetry works there. So they will look the same in that first and third quadrant. Okay, so another investigation for you on your graphing calculator. I'm going to let you guys try this out on your own. If you want to throw that in Desmos, if that's easier, that's fine. We will discuss these results in class, either in your small groups or together as a group if we need to. So make some notes on what you notice there when you graph those, and we'll talk about them in class. Okay, so as we're graphing, this is one form of graphing that you'll see, a divided by x minus h plus k. And so that h and k should look familiar to you. You'll notice that a tells you the orientation, and that's one of the things you should have noticed when you were graphing. So it tells you whether or not it's flipped over the axis, if it's negative. Vertical asymptote, x equals h. So that's where the denominator would equal 0. That's the line that will not be crossed on your graph. So on your parent function, it's going to be the y-axis, but if we've moved left or right, it's not always the y-axis. Horizontal asymptote is y equals k. So just like on your parent function, it was the x-axis, but it may be moved up or down. Plot 2 points on each side of the vertical asymptote to graph this. So if we take a look at this first graph, we see that our vertical asymptote would be at x equals 1, and our horizontal asymptote would be at y equals 2. So the first thing I typically do is just draw that in, because then you can see kind of a new axis that's formed. So then if we pick 2 points, I just make a table. I need to pick 2 points to the left of x equals 1 and 2 points to the right of x equals 1. So two numbers bigger than x equals 1 would be 2 and 3. Two numbers smaller than x equals 1 would be 0 and 1. So if I plug in 2 for x, I get 2 minus 1 in my denominator. So 3 over 1 is 3, plus 2 is 5. If I plug in 3 for x, I get 3 minus 1 is 2, 3 over 2 is 1.5 plus 2 more, I get 3.5. I plug in 0 for x. 0 minus 1 is negative 1. 3 divided by negative 1, negative 3 plus 2 is negative 1. If I plug in negative 1 is smaller than 1, not 1 is smaller than 1. If I plug in negative 1, I get negative 1 minus 1 is negative 2, so 3 divided by negative 2, negative 1.5 plus 2 would give me 0.5. So then I'm going to plot those points. I'm going to go over 2, up 5, and over 3, up 3.5. So this right-hand branch looks like this. And then 0, negative 1, and negative 1, 1/2. This left-hand branch looks like this. The other way that you might see this is ax plus b over cx plus d. So you'll have two linear pieces there divided by each other. So the vertical asymptote is where the denominator is equal to 0. So you'll just set that whole denominator equal to 0, find out what it is. The horizontal asymptote is just going to be your two slopes here, a divided by c, the two things in front of x. So the coefficient in front of x, a divided by c, is going to tell you your horizontal asymptote. You'll plot 2 points on each side of the vertical asymptote just like before. So here we have x minus 2 over 3x plus 3. So for vertical asymptote, we want to know where 3x plus 3 is equal to 0. So subtract 3, so 3x equals negative 3 divided by 3. So x equals negative 1 will be your vertical asymptote. Horizontal asymptote, we're looking for the coefficients in front of x, so y equals 1 over 3. Then I'm going to pick 2 points bigger than negative 1, so 0 and 1, smaller than negative 1, negative 2, negative 3. I'm going to go ahead and plot my vertical asymptote. And my horizontal asymptote. So now I'm going to plug in for these 4 points. Go ahead and do this on your own if you want to pause the video. So I get negative 2/3 with 0. I get negative 1/6 with 1. I get 4/3 or 1 and 1/3 with negative 2. And I get 5/6 on negative 3. So 0, negative 2/3, and then 1, negative 1/6. So what I notice here is that it's flipped to the opposite branches here. So then I have negative 2 and positive 4/3, so 1 and 1/3. And I have negative 3 and 5/6, so not quite 1. And there's my other branch. Alright, the last piece is a graphing calculator activity. That's on page 316 in your book. This is something we will also talk about. It's sketching it, stating the window used to give a good view. We've talked a lot about setting up the appropriate window, so if you want to take a look at that ahead of time, that would be great, and then we will talk about it in class. If you have any questions, feel free to come see me. Otherwise, I'll see you in class.